Good morning and welcome to Earth Science. We're going to be studying earthquakes today, as you can tell from our background, and we're going to be doing guided notes in a summary style format. That means I'm going to give you a summary or a theme main sentence, and you will elaborate your notes below that, writing what you think is most important from what is mentioned in the video. Now, there are two different ways that you can do this. You can either print out your guided notes, or you can utilize the Google Doc that I've made and type into the boxes below each of the summary statements. Now, with that way, it can be sort of difficult unless you know how to either split your screen or have a secondary device. A secondary device to play the video, it's a YouTube, again, video, could be just your phone, and that way it frees up your device to just worry about typing. Now, anyways, we're going to get started learning about earthquakes. Have a great day and take care. Okay, earthquakes. An earthquake is the vibration of the earth produced by rapid release of energy within the lithosphere, or the Earth's crust. Earthquakes are caused by slippage along the break in the lithosphere called a fault, and faults are fractures in the earth where movement has occurred. Remember that in the website that we visited today in class that showed us the latest earthquakes, there are these fault lines, these major fault lines, where, again, the plates of the earth were, again, meeting. And when we have a sort of catch, whether that is one plate going underneath, one colliding, trying to slide past, and we have this catch that movement is inhibited, you have this buildup of energy that is then released rapidly in the form of an earthquake. So let's talk about faults and the Earth's surface. The movement that occurs along faults during earthquakes is a major factor in changing Earth's surface. So land can shift in tens of meters in one earthquake. Think about how much a meter is. A meter is about 3 feet if we're comparing it to your standard versus metric. And crust can move both up, down, vertically or horizontally. So up and down or left and right. The crust that moves vertically has been uplifted and will produce sharp ridges called a fault scarp. And crust that moves horizontally is usually offset or displaced. Now, the San Andreas Fault is probably the most famous fault line in the United States. It is a transform, or what we call a strike-slip fault, and it extends about 1,200 kilometers through California. It forms the tectonic boundary between the Pacific and the Northern American plate, and earthquakes occur on the fault about once every 22 years. Okay, we're going to talk about faults and epicenter. These sometimes can get confusing. So let's talk first about what a focus is. The point within the earth where the earthquake starts is called the focus. Now look at this picture below. You're going to notice that the focus is below land because that's where, again, the earthquake is starting. Now, again, it's located at a fault beneath the surface, and the energy that is released travels in all directions in the form of seismic waves. The epicenter is where, again, directly above the focus, where it meets the Earth's surface. As I said before, the epicenter is the location on the Earth, again, the surface of the Earth, directly above the focus, and is where the earthquake is the strongest and where the most damage occurs. So you'll always hear people ask, well, where was the epicenter? Where, again, this could be also, where's the most damage? Where's the strongest magnitude that we see? Now look at this picture. You'll notice that the fault, the epicenter, and the focus, they can be located at different places from the same earthquake. Make sure that if you that you have this picture and that it is hopefully diagrammed if you're drawing or whatnot. So, causes. What causes an earthquake? It could be a couple different things, but mainly an earthquake occurs when frictional forces on the fault are overcome. You have the elastic rebound hypothesis, and that explains that Most earthquakes are produced by the rapid release of energy stored in rock that have been subjected to great forces. When the strength of rock is exceeded, it breaks suddenly, releasing some of its stored energy as seismic waves. One of the reasons why I wanted you to watch that video before we started these notes was that you could get that understanding of the plates sort of rubbing and building and sort of locking in place until they're forced and broken to release that great energy that we see in an earthquake. Now, aftershocks and foreshocks are also release some of the fault's stored elastic energy. So aftershocks, that means that these are small, again, earthquakes that occur after. Foreshocks are the ones that come before. And aftershocks can continue hours, even weeks afterwards. And again, they're usually weaker. They can still be strong, but they're usually weaker. And a foreshock can occur days or even years before a major quake. Seismic waves are waves of energy that travel through the Earth's layers. Now, if you've ever had physical science or you're going to take a physics class or have taken a physics class, you talk about these waves. We're mainly going to be talking about P waves and S waves, but the main thing is that these waves are results of earthquakes, magma movement, man-made explosions, volcanic eruptions, large landslides, but you'll see that the motion of the rock in this picture is in the direction of the S wave. And why it's called an S wave, because you can see that S shape of wave movement. Now, we've got types of seismic waves. We have earthquakes produce two main types, body waves and surface waves. And waves travel differently in wave motions and in speed. Now, waves that travel through the Earth's interior are called body waves. And think about that. Something that's on the surface versus inside the body. Body is the main components inside. Think of it that way. So you're going to remember Earth's interior. Surface is obviously on the outside exterior. Now, the two types of waves are, again, P waves and S waves. Look at the difference. It may be something that you may have to do on a test, is identify what is a P wave versus what is an S wave. Make sure that you have, again, these drawn somewhere in your notes, even if you have to take a loose leaf sheet of paper and draw them separately. Now, P waves